Good morning, everyone. Welcome back to Quant Questions, where we go over questions commonly asked in a quant interview. Today's question is high or die. Going straight into the problem, Francisco rolls a fair die and records the value he rolls. Afterwards, he continues rolling the die until he obtains a value at least as large as the first roll. Let n be the number of rolls he performs after his first roll. Find the expected value of n or e of n. I'm going to give you guys 3 to 5 minutes to think of a solution for this problem. Remember, this is a problem on probability and expected value. It's also an easy problem, but if you need to take more time, take it. Don't go straight to the solution. Alrighty, now let's get to the solution. We need to first acknowledge how likely is it to obtain a value that is at least as large as the first value depends on the first value itself. So in simpler layman terms, if our first roll is 1, it's going to be a lot easier to get a value greater than 1. So n is going to be smaller. So we need a condition on x1, which is the value of the first roll. That means the expected value of n is the expected value of the expected value of n given x1. Given x1, there are 7 minus x1 values on the die that are at least x1. This is just a general formula we can create for each value. So say 1. 1 will have 7 minus x1, so 7 minus 1, 6 values on the die that are at least greater than 1. From this, you can see that for 2, we have 7 minus 2 is equal to 5. There are at least 5 values on the die greater than 2. So if our first roll is 2, we have a 5 over 6 probability that the second roll is going to be greater than 2. From this, we can get the expected number of rolls needed is the inverse, which is 6 divided by 7 minus x1. So now we have a value for expected value of n given x1. And we can plug this into the equation and use Lotus to solve it. So Lotus is just a law of the unconscious statistician. And it basically means that we have an x1, which is a variable. We can sum over all possible values of x1. And we get that the sum of 1 to 6 of 6 divided by 7 minus I times 1 over 6, which is the probability of getting that value, is 49 over 20. And as you can see, if we submit 49 over 20, that is the correct solution. So once again, thank you guys so much for watching. Make sure to like, comment, subscribe, and I'll see you guys in the next video.
Mom, somebody just followed me.